graphed things that, have you heard the word asymptote before? You have. Okay, perhaps. Do you remember when and where you have heard that? Coach Wood? Was it just mentioning it, or did you guys do something with it? I don't think you do anything. Yeah. I don't think there's anything in the Math 1 curriculum where you would really in-depth look at these before. So we're going to have a special feature on these graphs called asymptotes that we have to learn about. And to introduce that, let's make a chart so we can graph 1 over x. Okay? So, to begin with, if I plug in 0, what do I get? I do not get 0. I do not get 1.
You don't get any number because 1 over 0 is...
There's a word for 1 over 0. It starts with a U. Not U. Undefined. Yes, undefined. Undefined. Okay. I did not hear it. Alright. So, undefined. So, undefined means that you can't graph anything for 0. If I plug in 1, what do I get? 1. So, I'm going to put a dot at 1, 1. If I plug in 2, what do I get? 1/2. So, I'm going to put a little dot right here. If I plug in 3, what do I get? 1/3. And so, I'm going to try my best to make that look like 1/3 right there. If I plug in 4, what do I get? 1/4. And I'm struggling right now to make these look any different, right? What's going to keep happening? 1/5, 1/6, 1/7, 1/8, 1/9, 1/10. Will 1 over x ever get to 0? Okay, it will not. But it's going to get closer and closer and closer and closer and closer and closer to 0, right? Once we're out at 1,000, 1 over 1,000, or 1 over 1,000,000, or 1 over a gazillion, it's so close to 0 that it really doesn't, it's not any different. So the way that we're going to draw this in on this side right here is we are going to draw in the line and just try to get, closer and closer to that x-axis. It's fine if it touches. It just never should cross that x-axis, because essentially when you're graphing 1/10 and 1/11 and 1/12, you can't tell the difference unless you're really zoomed in on whether or not that touches 0 or not. So, now that's for this piece. This is undefined right here. So, I don't really know what to do with my graph over here. So let's try doing this. Let's try plugging in some numbers that are between 0 and 1. So for example, let's plug in 1/2. Okay? So if I plug in 1/2, 1 divided by 1/2. What do I do when I divide fractions? Okay, so that top will be 1 over 1. And then flip the second and multiply, so it's 2 over 1. So that's just going to give me 2 over 1, which is 2, right? So if I plug in 1/2, which is right here, I get 2. It's going to be kind of similar, right? Because if I plug in 1/3, what do I get? 3. So like 1/3, which is hard to draw, is at 3. And 1/4 would be at 4. So the same thing kind of is going to happen here. As I get, that x value gets closer and closer and closer and closer to 0, my numbers keep getting bigger and bigger and bigger and bigger and bigger, right? So right here, what we're going to do is we're going to make this go up, 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 but it's never going to actually touch that line. Mine looks like it touches the line, but that's just because 1/10 is going to be so close to the line you can't really tell where it's at. So what we're dealing with here, these are called asymptotes, right? Because we get closer and closer and closer and closer and closer and closer. But we never actually get there. So let's do this. I just like this problem right here. I'm going to pause this because it's still. So right-hand side of the graph. Let's consider now what happens if we plug in negative numbers. So let's say we're going to have, if we plug in -1, we'll get -1. And if I plug in -2, I get -1/2. So -2, -1/2 would be right here. And -3 is going to be -1/3, which would be about here. So what's going to happen right here on this side of the graph? We'll have -1/4, -1/5, -1/6. So that also gets closer and closer and closer and closer to 0, but from underneath, right? So this graph, this piece of the graph is going to look like this right here. And then if I were to plug in numbers like -1/2, 1 divided by -1/2, dividing fractions is easy as pie. Flip the second and multiply, I'll get -2. And then if I plugged in -1/3, I'd get -3. So we'll have here and here. And that's just going to get closer and closer and closer and closer and closer there as well. And let's see, Katie, let me get A. Okay, so the parent graph for this, I'm not going to make you graph all of those little points because I'm not going to be able to tell the difference between your 1/2 and your 1/3 and your 1/4, just like you can't really tell that much of a difference for mine. So when we graph the parent graph for this, you don't have to, but what I suggest doing is using a dotted line. Oh, that's not dotted. I meant for it to be dotted. A dotted line. But it needs to be a different color than black so that you can see it. I'll get it together here in a second. Okay, now maybe I've got it. Oh yeah, there we go. A dotted line for those asymptotes, right? And so if you put those dotted lines there, I want you to include the 0.11 and 1 -1, and then you don't have to actually draw in the other points. Just draw, draw the graph as best you can. You don't have to put points there for those. So on these, I'm going to be looking to see that you have the asymptotes correct. You don't necessarily have to draw the dotted lines, but if you cross the line that you're not supposed to cross, you're going to, not get it right. So I think it helps so that you can see it there. The dotted lines are not actually part of the graph. They're just there for us to see. We get closer and closer and closer and closer to this line, but we never actually touch it. So, for the domain for this, when we're thinking domain, we're thinking about what x values we have. There is only one x value where we've got nothing. What is it? It's 0. When we tried to plug in 0, we got undefined, right? So, the domain here, you can write it two ways. I prefer this. X cannot equal 0. So all real numbers except for 0. Or you could do -infinity to 0 with a parentheses. And this upside down U that I'm going to draw right here, that means and in this notation, 0 to infinity. And that, I would just put x cannot equal 0. That'll be easier. But just in case you were to see this, this would mean from negative to 0, but not including 0 because I did not use a bracket. I used a parentheses. And then from 0, not including 0, up to infinity. So it's everything but 0. I wouldn't write it like this, but just in case you were to see it, you've been exposed to that. And so whenever we talk about the y values, what y value can we not have? It's also 0. Right? So that y, right there, y equals 0, we don't have anything on that line because there's nothing we could plug in that would give us 0. If we plug in a positive number, we're going to get positive numbers. If we plug in negative numbers, we get negative numbers. If we plug in 0, we get undefined. So we can't get 0. So our range is y cannot equal 0. Or you might see negative infinity to 0 and 0 to infinity. Okay. On these problems, you can have vertical stretches and shrinks like we did with the square root problems. However, they become really difficult to graph. So I will not ask you to graph one that's been stretched out or shrunken down here by hand on these. I might possibly ask you a question about it, but probably not even that. I'll probably leave those to the square roots. So let's look at our first problem here. We've got f of x equals 1 over x plus 2 minus 3. And so we don't have any parentheses here, but where would there be understood parentheses? X plus 2. That is down there in the bottom with x plus 2, or with the x, so that is understood parentheses. So with that x plus 2, Adam, what's that plus 2 going to do to the graph? Very good. Left 2. Okay? And Brandon, what is the minus 3 going to do to the graph? Down 3. Okay? So, since I have this nifty computer here, I can do this. I am going to take my x and my y-axis. I'm going to put my dotted lines for my asymptotes, right? So I need to move the graph to the left 2. So I'm going to take this vertical asymptote right here and move it to the left 2. I could move the horizontal one as well, but it's not going to do anything. It's just sliding right on top of itself. Then I am going to move the horizontal asymptote down 3. I could move this one as well, but it's not going to do anything because it's going to be sliding up and down. All right. So these are my new asymptotes, right? I've moved the horizontal one down 3. I've moved the vertical one left 2. So I know that my graph is going to go through this point and this point, and then I'm just going to draw in my lines and have them get closer and closer to that asymptote, but never, I mean, in reality, mine are going to touch the line, but just at least make sure yours doesn't cross the line. Because if you draw it like this, then I'm going to count off, because that would be wrong. You don't want it to cross that line. So it just gets closer and closer and closer. Okay. If you're doing domain and range for these problems, on the square root problems, I gave you a way that you could tell domain without actually having to graph it. We can do the same thing here. Whenever we're looking at this problem, and we did this some when we were solving those rational equations, I know I cannot have a 0 in the bottom of a fraction, right, because that gives me undefined. So I could just take x plus 2 and say that cannot equal 0. So if I move that 2 over, I know x cannot equal negative 2. Or you can just look, and you can see right here that, like if you look at this point right here is at negative 2, negative 3. That's where the asymptotes intersect. The x coordinate is negative 2, so x cannot be negative 2. Okay, the range in this case is going to be y cannot equal negative 3. And just like with the square root functions, the only thing that's going to affect that range is whether or not you've moved something up or down. A flip is not even going to make a difference for this one. Okay, questions? All right, here's our next one. We've got 1 over 2 minus x. Is this the next one you guys have?
Yeah.
Okay. Hold on. Oh, I don't mean for these to both be the same. Or do I? Okay, one's got a negative. Okay, yes, that's fine. Oh, wait. And this one has a negative, but really I don't want that 2 minus x in both places. Let's change that. Let's change this one. And they both say, have I got them backwards? I do, don't I? I've got 3 before 2. Alright, so let's change the second one. The one that says it's example 2. That's in the wrong spot. Let's make it x minus 2. There, because I don't really want us to do the 2 minus x in both places. In fact, let's do that example 2 first before we do the other one. Okay, so fix that and change it to x minus 2. This has parentheses around it even though they're not written. Roxana, what's that minus 2 going to do to the graph? Is going to be to the right 2. Very good. And Stephanie, what's the plus 4 going to do to the graph? Up 4. And Trace, what does the negative that's out front there do? Flip over the x-axis. Flip it upside down. Alright, so just like, I actually do these. I do the flip last. And you'll see how we do it here in a second. You could flip it first. But I'll show you what I do instead. So let's do some pink lines. Oh no, those don't show up. Oh, no, how about this color? I think that'll show up. Oh yeah. Alright, so normally your x and y axis would be your vertical and horizontal asymptotes. So we need to move this to the right 2. So you could go ahead and draw in your dotted line there at x equals 2, that vertical line at x equals 2. And then we also need to move our horizontal asymptote up 4. There. So if you want to go ahead and draw in those asymptotes. And we haven't even written that word down. That word is asymptote. Asymptote. It's a weird word. Yeah. Yeah, it's a weird word. Okay, so these, I guess I should put S on it. Those are your asymptotes. You have a vertical and horizontal. Alright, so the difference in this one is our points have been flipped. So normally our points would be right here at what the new 1, 1 would be, and negative 1, negative 1. So we're just going to flip those. So instead of having a point up here, we're going to have the point down here. And over here, instead of having the point in the bottom, we're going to have one in the top. And then you're going to draw in your lines for your graph. And so the good thing about these is that flipping your graph really does not affect anything, because flipping your graph didn't move the asymptotes, and that's what gives us our domain and range here. So for example 2, our domain is x cannot equal 2. And then our range would be y cannot equal 4. Okay, questions? I don't like graphing these, but they're really not that difficult. I just don't like drawing them. I think they're ugly graphs. And kind of hard to draw to get them to look pretty. I like quadratics better. So, questions on that one? Alright, so let's go back to the example 3 that was out of place there. Alright, so this one appears a little bit different than what we've seen so far, because in the parentheses I don't have x minus 2. I've got 2 minus x. Can I just switch those back? I cannot. If it was addition, it would be fine. If you have 2 plus x, make it x plus 2. It's going to be moved to the left 2, right? So if it's addition, it's fine if they're out of order. But if it's subtraction, it's not okay. So in order for us to be able to graph this correctly, we've got to do a little bit of work on this 2 minus x. Yes?
Can't you flip them?
You can flip them. You can make them like this and make it negative x plus 2. But do we know what that negative right there is going to do to anything when it's on the inside of the parentheses? We don't. A negative on the outside of the parentheses is going to flip it upside down, right? Flip the graph upside down. But a negative on the inside, we don't know about it as much. So, this is what we're going to do. I don't want to have that negative there. So, I'm going to factor out a negative 1. Okay? So, greatest common factor, I'm going to pull out a negative 1. So, when I do that, I will have x, and then that positive 2 will turn into a minus 2. Now my negative is on the outside of the parentheses, right? So let me write our equation, what we've got now. We've got 1 over negative 1x minus 2 plus 5. Okay, so by factoring that negative 1 out, now it's on the outside. Now it is going to flip over the x. There. Okay, so that negative right now is going to flip. And now we have it where it's an x minus 2, so we know what that does, right? That's going to move it to the right 2. And then over here, this plus 5, it's up 5. So if you see one that's backwards in its subtraction, factor a negative 1 out to get that negative on the outside. And it'll also make your x look right on the inside. Okay, questions on that? Alright, let's, dotted line. So let's graph this one. Alright, we need to move this graph to the right 2. We need to move it up. Ooh. We need to move our horizontal. I'm in trouble here. There we go. Up 5. And then we are going to flip the graph. So rather than having the points in what would be sort of like your first and third quadrant, it's going to be second and fourth. So it's going to be here and here. And you'll draw those in. And so our domain here is x cannot equal 2, and our range is y cannot equal